Hi and welcome to this webinar. My name is Lucas Thiel. I am an architect and a partner at White Arkitekter, and I will be the moderator for this. This is a webinar on building integrated photovoltaics, the key to reach net zero carbon goals. And the aim is to shed some lights on how building integrated photovoltaics, in short BIPVs, can help us reach net zero carbon goals. This seminar will be recorded and made available at a later date. And there will be presentations from 3 speakers that I will present, and also a short Q&A after each presentation, and a longer Q&A, hopefully, at the end of all presentations. And if there are questions raised that we do not find time to answer in the webinar, we will post them later. Yes, and the speakers this morning are David Larsson, Senior PV Consultant at his own company Solisten, and former Head of Research at Solkompaniet, and he has experience from international research. We also have Maria Lundgren, Senior Sustainability Advisor and Partner at White Arkitekter, with experience in BIPV through projects and in international resorts. And this is both on urban and at individual building scale. And last but not least, Rickard Nygren, architect at White, focusing on net zero carbon buildings, energy efficiency and solar energy in the built environment. Rickard is a BIPV expert in IEA PVPS Task 15 and in the EU Horizon 2020 Be Smart Consortium. And this is organized within the framework of Be Smart that has received funding from European Union's Horizon 2020 Research and Innovation Program. And following this seminar, there will be 2 workshops, and those workshops will be held on September 15 and 17. Unfortunately, not available in English, it will be Swedish only, and more information on how to register will follow shortly. So first, I would like to welcome Maria.
Thank you. And I will talk about early planning and BIPV and cultural heritage. I'm just waiting for us to start showing. So building integrated photovoltaics have a great potential to serve several purposes, giving us clean renewable energy and making the building and fabrics more robust when it comes to energy supply, as well as being a building material. We have to be aware that the plans we set now affect the potential of solar energy for a long, long time ahead. Active solar can lower the demand on energy for central energy production by producing it locally, even though the city expands or becomes densified. Urban planning can enable and higher the degree of implementation of solar energy in our cities, creating good conditions for active solar. This can be done through carefully locating the buildings, giving enough space between the buildings, and giving room for details that can offer conditions for photovoltaics. And planning of solar energy can, if done wisely, also create good conditions for daylighting, become coordinated with greenery and trees, and thus contribute to ecosystem services and lowering the temperature in urban areas, which we not the least have seen this summer how important it is as the climate is changing. Planning must prepare the path. And another part of planning is to bring forward the ideas in very early stages. That has to be done since what is actually laid out in the legislative document, the detailed plan, is of utter importance. And a project I will talk a little bit about, through the Parken in Uppsala, White contributed at the early competition stages with suggesting not only the form of the building that becomes more visible as one enters with the train to Uppsala. The White also presented the ideas to use photovoltaics as a key feature for the buildings in the new area to signal Uppsala's position as a photovoltaic research city, famous for the research and the world record in thin film cells in the early 2000s. And these pictures illustrate the very early sketches or project drawings that were developed further from the competition. And in 2008, a little bit later, Uppsala City Council appointed Uppsala Hem AB as the landowner for Frodeparken and Skanska Nya Hem for the other parts of the area. And Uppsala City Council also stated the importance of energy efficiency and the use of photovoltaics. And at that stage, we also needed to show that this was economically viable for Uppsala Hem. And we addressed the company where David, our next speaker, worked at the time, Solkompaniet. They presented a life cycle cost analysis that showed at the time that the facade would be paid off in 20 years. And this made it really interesting for Uppsala Hem, who is a long-term municipality residential owner. And by the time it was built, this payback time had shortened to approximately 15 years due to the market growth of PV, and with that came lowered prices. And at this point, I also suggested that instead of the blue facade of crystalline cells that was commercial at the time, we would try to use the upcoming commercialization of the world record thin film cells from Uppsala that has a more grayish, blackish color. Due to the change of the color, this was something that had to be discussed over a period of time with Uppsala Planning Office and also required a decision. So just to point out the relevant aspects of the plan. And the facade faces the optimum direction of maximum solar exposure over the day from the early morning to afternoon. Energy-wise, it covers half of the real estate electricity by its 675 square meters of photovoltaics in the 900 square meter facade. And the ground floor has a glazed frontage without PV and could accommodate shops and kindergarten. And the idea also with this glazed fronting was to a precaution, since we knew that a new building with uncertain heights were to be built in the future in front of Frodeparken. You see the triangle in front. And in that development plan, the number of stories were controlled, but not the heights. So we had to be very careful. And the lower areas are the ones that are most shaded, and this has worked therefore very well. I will speak a bit about conservation areas and cultural heritage. When it comes to this, an approach to address photovoltaics has been developed by researchers in Switzerland that we at White has been working with in several energy agency projects over the years. We have also used it in a pilot study in Stockholm that I will show a bit about. And the researchers had for some time seen a backlash for solar energy due to the fact that building integration had occasionally taken place in a way that disturbed the cityscape and created counter reactions among the citizens becoming negative to photovoltaics. And here in Sweden and in the rest of Europe, we certainly and the world have a historical context worth preserving. And at the same time, we will probably see a stronger increase of photovoltaics that is a new material, which places demands on planners, building heritage consultants, as well as the designing architects. And the methods that they presented in Switzerland was comprised by 3 parts. It's a sensitivity study that values the building and environment and how it is resistant to minor and major changes without losing in value. And then the visibility study that is most easily can be described as something that estimates the degree to which the surface can be observed from different places. I will come back to that. and it's put into a matrix where the resulting requirements are different depending on how sensitive the area is, and therefore the quality of BIPV is differently required. And this quality is something that can be assessed and evaluated by building heritage specialists, architects, and related to the building and planning ordinance that we have in Sweden. And as we already have ways of determining the sensitivity by cultural heritage assessment, in this pre-study in Stockholm that we did, we coordinated our already used methods with the LESO QSV approach from Switzerland. And our team consisted of urban planning competence, me being an architect, and a cultural heritage specialist. And I will show you pictures also. So I will go through this steps. What you can use is an existing solar map or develop a potential study, but most municipalities in Sweden and around the world have existing solar maps. We determined a profitable threshold for the annual solar radiation. We looked at the classifications of the sensitivity of the buildings, and we overlaid the classifications with the threshold values where it's economically viable. And then we conduct a visibility study for the areas. And here you can see the first two steps to use the Stockholm existing solar map, but to determine a threshold that we laid at 950 kilowatt hours per square meter a year. And then we looked at the classifications already done over this area, gasklockan. And then we overlaid the sensitivity classification and threshold values. And by that, we knew which buildings we were to look at more closely. And then comes the method for assessing visibility. And you can do it in different ways. And this is also something that I think will be developed further on. But you can do an on-site survey based on the knowledge of important places for views. You can make a qualitative study of photos and 3D models, or a computer compilation. And you can do a quantitative study similar to what we do with daylight or noise. But you need a special software, and that has started to be developed in Switzerland. And in the Swedish cultural heritage assessment, there was also a couple of concepts that were very important. It was important that any additions and alterations would be clearly legible, and a case-to-case study to show whether the alterations should be modern and contrasting or mimicking. As we have not integrated PVs right now in gasklockan, I will show you some examples of the possibilities of PV regarding these three concepts. If you want to mimic with classical materials like tin-like surfaces, there are many photovoltaic producers today that offer materials like this that can blend into existing areas, such as this one in Copenhagen. When it comes to modern and contrasting surfaces, we can also look at all the projects around Europe and the world that have a high quality and be inspired by that. Therefore, I want to show you a homepage that has a collection of projects. It is, again, an energy agency project, an international energy agency project, where I was one of the experts. And with an interdisciplinary group, the architects, or the ones with the background of architects, served as a jury to choose what projects were relevant from a high quality architectural point of view. And then they were described technically and architecturally. And for each project, you can download several pages of information. And among these, you had 5 Swedish examples. And among these, I would like to show you the KTH Auditorium in Stockholm, an original building with a high cultural heritage value, where a clearly legible, modern and contrasting and respectfully integrated PV add-on a new layer to the new building. And the architects are Arkitekter. And another project, an internationally well-known building with clearly legible additions, is the Berlin Reichstag, made by Norman Foster. I'll just show you a little bit about that. This is the clearly legible addition. And when it comes to the PV, they are actually hardly visible. They're somewhere among these roof areas. And in a conservation area, it's also important to look at the area around. And this area is an area with a lot of buildings where the political powers sits. And they have a lot, many of them are covered with PV. So here you can see a detail of that. And I'd like to also show you that in this LESO QSV method from Switzerland, they have produced a homepage where you have a lot of different buildings, over 100 of different architectural quality. And a municipality in Sweden or a national forum could actually sit down with a lot of competences and use this database to designate examples that can be illustrative to sensitive and non-sensitive, less sensitive contexts. And ending off there, I'd like to show you an addition of PV roof. This is a new build, but it can also show what you can do in existing areas. And this is in Naturum Vattenrike, the sensitive national park.
Excellent. We have a couple of minutes for questions. Should there be one or two? If you're shy, you can wait with your questions to the final Q&A session. And then we will move on to David.
Yes, I will start my sharing. Hello, everyone. I hope you see my presentation now. I am David Larsson from company Solisten, and I will talk about money with you, BIPV economy. I will bring my experience from previous work at the IEA PVPS Task 15. I was one of the experts, just as Richard still is, a couple of years ago. And also an ongoing project called EST about a renovation with a combination with solar electricity or PV cells. And first, I'd just like to state that if you Google this IEA PVPS Task 15, you will also find reports and a new report with more examples, good examples of BIPV. And I will show a few of them in my presentation. First, a few words about the environment. As you all know, we need to put a lot of effort in the coming decade, a lot of hard work towards a healthy climate. And my view is that PV should be on every building, at least every new building. And when you work with renovation of buildings, you should always at least consider PV. And I would also like to encourage all Swedish participants to try this tool, online tool, or you download the tool. It's free of use, called Tidsstegen, where you can evaluate all energy measures in buildings from a climate perspective. And then you will find that PV is actually one of the most effective building measures you can introduce to your building. And using the calculations in this tool, you will find that the minimum climate benefits of solar electricity added in the Swedish to the Swedish electricity system is minus 400 grams CO2 per kilowatt hour, and it could be even more. So that's more than most people know, and that's more than most of the other competing technologies. So yeah, that's my starting point. But that's not what I should talk about. I should talk about money and the BIPV economy. And in a nutshell, these are the findings from the work I was included in the the EIA work, that you need to balance the investment of the BIPV system with the electricity production, the value of the electricity production, the value of replacing other materials, and the value of the increased status of the building. And this could be, we talk about green status in our report from the IEA, but of course it could also be a signal of a modern building or a very beautiful building. It's hard to quantify, but it's one important aspect, one important value from BIPV is the status of the building. And these qualities can also be transferred into, electricity production can be used to reach energy goals. So indirectly, that's another value. And these energy goals can lead to that you have a certification in BREEAM or LEED or Swedish Miljöbyggnad. And that in turn can also higher the property value. More people would like to rent or buy a building which has these certifications. Furthermore, the electricity production will also reduce the running cost for the building, and that could also tends also to higher the property value of the building. And last but not least, the status of the building can also, of course, increase the property value. So these are the aspects you need to keep in mind to be able to make a profitable investment in BIPV. And now I go on a little bit more about the investment. Of course, if you can have a lower investment, it's easier to make a profitable project. And then it varies quite a lot from the simplest installation, which is actually a standard PV installation, but designed in a good looking way. So I call this virtual BIPV. And it's significantly more costly, if you go for the full BIPV facade with customized modules and colored glass. But you can also, of course, have a higher value of such a building. This status of the building could be much higher. And in the middle, we have some simple BIPV with serial produced modules, like the example in Frodeparken, which Maria talked about. That was one key aspect, to have a quite low investment for that project. And I will present now these different variants a little bit more in detail, or say a few words about each, and also highlight some key aspects from an economical point of view. Sorry, first, I just want to highlight that in these cheaper cases, you mainly just need, you generally just need the value of the electricity to be profitable. When you introduce these a little bit more expensive, you also get the opportunity to have the value of replacing materials, which you do not in the first. So that could also be profitable projects. And the higher up you go in the investment cost, the more you are dependent on the status to include that, the value of the status as well, to find yourself a profitable project. And of course, if you make the design so that you can do the cheaper PV installations, but still have a high status of the building, that will be a more profitable project. So now a little bit more in detail. This is a project which is highlighted in the last IEA report I was talking about. So this is actually a standard PV installation, more or less. The big thing is that you design the building so it can be this good looking anyway. And this is a simple BIPV installation where standard PV modules are used to replace the roof tiles, which is also then quite good looking and not so much more expensive, or could even be less expensive than first adding a new roof and putting PV on top of it. But key aspects to be able to do these kind of simple and good looking installations are, of course, that you need to avoid obstacles. So when you plan a building, if you want to go for the cheap BIPV, you should really plan your building with rectangular areas with no obstructing objects where you want to put the PV. If you cannot do that, if you have windows like on this roof or other installations that you cannot get rid of, then you will probably need to go for these kind of full BIPV solutions or using this kind of products, which is available for steel metal roofs, metal sheet roofs, whatever it's called. Or there are also products for with solar roof tiles, which could then be more flexible and could handle more difficult roofs. On facades, we also have the possibility to use serial produced modules, as in Frodoparken, which is then quite cheap, could be profitable just when you replace other materials and have the electricity, the value of the electricity. Here too, you can have a facade with no obstructing obstacles, but that's quite rare. More often you have at least windows that you need to handle. And so one key point is generally then for the facade that you need to have a full system with dummy modules. I mean, these kind of modules which are not active, and it's good if they can be produced quite cheaply. Sometimes they are at least as costly as the PV module if you don't have a system where this is really included. You need to custom make these. So that's one key point, to have a system including dummy modules in a cost-efficient way. And finally, the full BIPV, of course, then there are endless possibilities. You can have a facade like this in Copenhagen with colors and customized modules. One key point even here, if you want to reduce the cost, is to try to limit the number of unique modules. So in this case, they have done it quite smart. They are the same shape of all modules, and all modules are tilted in a little way, and then they rotate this module on everywhere they place it. So we have this stunning effect and shimmering effect, even though all modules are produced the same way. So that's one good example of how we can do spectacular design in a cost-efficient way, or more or less cost-efficient way. I'm wrapping up with one important aspect when it comes to cost. It's not just about what kind of modules you use. It's also really, you need to plan the project according to the competences available where you are. I mean, this can also vary from country to country or city to city, even probably. Well, of course, people can travel there, but at least from country to country. I just need to stress that in Sweden, there are hundreds of PV installers, but only a few of those have experience in BIPV. And I would say that, yeah, BIPV facade is something that most PV installers are not familiar with. On the other hand, there are also, of course, traditional facade building companies, but they are generally not experienced in PV. And the same goes for roof builders or roofing companies. They are generally not experienced in PV. So this is still something that needs to mature in the business. And thus, it is important, if you want to have a successful project, to make your tendering documents clear, that there are clear interfaces between different subcontractors, because most PV companies could be able to make a BIPV installation if the planning is made for them. So it's not so easy, not so difficult, not too many business risks they need to take, because that will higher the price for you as a project developer. So I will wrap up with a short summary stating that BIPV is a way to increase property value. That's a good thing to keep in mind. Planning is very important for a successful project. You need to try to avoid obstructing obstacles. It's very good if you can reduce the number of unique PV modules, or even go for the serial produced ones. And last but not least, you need to plan the project for the available competencies in order to reduce risk additions to the price. Thank you very much. That's my presentation.
Thank you, David. This was very, very good. Lots of tips on how to integrate, and cost is always foremost, especially at the early stages. So now, if there are questions, well, I haven't seen. I could ask you about maintenance. It's always a question. You know, you have one budget when building or constructing or planning a building. Sorry, there you are. And then the maintenance comes from a different budget. What could you just comment very briefly on maintenance and the cost for maintenance?
Most people in the PV industry would probably say you don't need any maintenance for a PV installation. That's more or less true. Of course, things can happen. So it could be an important aspect to have some spare parts. I mean, if you have custom-made modules, that could be expensive to produce just a few ones if something breaks. And even if you have serial produced modules, they tend to develop quickly, and a few years from now you might not be able to get them anymore. So having a few spare parts could be a good something good. Otherwise, no, I would just, PV in general could be more or less considered as a glass module. So it's not, you need to maintain it as you do with a glass module, but you don't really need to clean it generally.
Yeah, and we do know how to maintain structural glazing. There's an interesting question here also about the comparison between roofing and facades, where you would want to know the efficiency of facades. Roofs are more or less, you know, a no-brainer. You have the right angles. So, would you say how much longer would you say it would be to break even on a facade system?
That really depends on how many values you can include. Of course, facades produce like 25% less electricity than a good roof. So then you can do the math. You need 20% more time to have the break even if you only count the electricity. But you will replace probably more expensive materials, and you will have much more possibilities to show off your building. So you need really to take those aspects into account as well.
Thank you, David. We have more questions. We will answer them at the end with the Q&A session. And as I said before, if we don't have time, then we will find time after the webinar and post them to everyone. Okay, great. So I would like to say the floor is yours, Richard.
Yes, we're going to look into how we have done work with this in practice in one example, a zero energy hotel here outside Stockholm. But first, I would say that one of the big arguments to use PV and BIPV in our projects is to meet the discussion on climate impact. And a building has got a climate impact, we know that, and we work hard to decrease the emissions from the building materials itself and the energy in use. And in order to put an extra incentive of this work to make us go even further, is to include balancing also to these emissions, that even though when they are heavily decreased, there are some emissions, and when we decide to balance those with, for example, using wood or different measures, but one important thing is to use PVs. And so we calculate the climate benefit from PVs. And here, if we see the result in climate declaration, on the bottom line, we have the benefit of the PVs in this project. And we can choose to work with this in an early stage when we set up a climate budget for the project. So we can steer towards a goal, and then we know how many PVs we want to use in the project to reach as far as we want. So we include the climate benefits of PVs in our project when we are calculating the climate impact. And when it comes to photovoltaics, it's usually the unit for carbon emissions per kilowatt hour is used, and that is very common way to describe the carbon impact from the solar cells. But when we work with buildings and introducing them into the building envelope and integrate PVs, we have to look on the production of the solar cells themselves and use other units for the climate impact per square meter of building material or building envelope, the facade or the roof. And that's a new way of evaluating, not a new way, but a specific way to evaluate the climate impact from PVs when it comes to integrated in buildings. And this must be said that it's easy to say that we shall do the calculations, but today it's really hard to get that information from the producers. A lot of producers, they don't present EPDs or clear information about the product when it comes to the emissions. So that is why it's good to highlight the few suppliers that actually present this. And one of them is the Swedish manufacturer of thin film in products for roof. And they have a really, really low emissions on the products. And so that is a task for us, everyone involved in the process, to ask for this information from the producers. Because of course we have to take that into account, not only the cost in money, but the cost in emissions, where to put these solar cells, if it's wise to put them on a facade, one or two facades. And this is what we're doing in our work when we build up our models, when we are designing the buildings, to simulate the power output in electricity we get, but also to get a better feeling of this payback time, environmental payback time that David just mentioned. So that is what we're doing when we're working in the design process in order to, yeah. So and that is what we have been doing in a recently finished project, a zero energy hotel built by BIPV hotel, also with office inside. And very much from the start, the lead architect found for himself a theme for the work. Since we were going to design a zero energy hotel, we let that ambition to reach for zero energy work as a guiding light for the design, to get an architecture that really was talking the same language as the energy performance. And here is a brief overview for where it stands today. It's the red dot in the middle, and in the east we have a very complex part of the city with heavy infrastructure structures, railroads, and in the west we have a green area with a small lake that the hotel itself is facing. So that is in brief the context. And neighboring our hotel is a big sports arena and also 5 high-rise residential buildings. And a little bit elaborating on the theme that I mentioned was that what we formulated that when you come to this hotel, whether you work or for a short stay, we try to find this notion of that you should be able to come there then get inspired by the environmental solutions that we presented in it. So you can go there and maybe bring back some new ideas for using PVs in your own home, and something else that might inspire you to be more ecological when it comes to what food you're putting on your dining table. And this way of thinking about the future uses of the hotel was repeated during the design process, and later on it was used for the tenant, the hotel itself, and they used it in their communication as well. So that was a nice thing to see, that idea, everyone in the process got involved in the same idea, and that made it easier to reach to the common goal. And of course, building integrated PVs is one of my favorite, but that is not the only thing that makes this to a zero energy house. Of course, the form factor, the ratio between the building envelope and the floor area is important to keep that low and have that efficient. The second step is to find a good balance between the window sizes to let the daylight in, to reduce the need of electrical light and energy for that. But on the other hand, to keep them low so we wouldn't lose energy from that, to find that balance. And the third is to find out the surfaces of this building that would be the most suitable to put PVs on. And this is in the beginning of the design process, and we should see how the photovoltaics on the roof here is actually contributing to the shape of the building. It's not a straight line, but keeping the PV modules on the roof together to make it as an efficient solution as possible, that gave this profile on the top of the building. So also the roof mounted photovoltaics gave its contribution to the architecture. And the facade is divided into 3. In the bottom we have the plinth that is kind of solid. In the middle we have the waist, where where even and smooth surfaces are mixed with more crude, giving a more articulated facade with a play with shadows. And above that, we have the crest with only smooth and even surfaces to have this facade divided into three. And that, even though that is a theme for the entire facade, whether it's included PVs, photovoltaics or not. So it's the same theme from the other facade as well as the big front solar facade. We have these smooth and even, we have it more crude with relief and articulation, and we have the third solar panel that is colored, the same color as the windows and the solar shading. And also, one way is to keep the number of different kind of sizes low, and also to keep the meshes of the panels in order to stack the PVs together and not have any empty and useless surfaces of the panel, but to have the panels filled with solar cells. And this building has got prefabricated facade, and that again stresses the importance of what David just said, that it's important to have that competence in the design process in order to have good tender documents to solve the eventual problems or describe the solutions in detail very clear. Otherwise, the contractors putting together the quotes will have a problem to fulfill the wishes, and that will create more discussions and maybe obstacles at the later stage that will ruin the economy of the project. So that is important, the early competence. Short, it was opened this summer. Fabege built the hotel. White was the architects, and Choice Comfort is the hotel tenant. Yes, and it's a zero energy building with 2,500 square meters solar cells together. We have them on the facade, the roof, and atrium glass roofs. So 3 different ways, where 2 are fully integrated, and the third one on the roof, you can call it virtual BIPV. And the result is when we look into the atriums, we have 2 atriums letting the light in. One is more strict, where the solar cells in the roof are more evenly spread out. And the second one is more vivid, also going along with how the rest of the interior in that atrium is. The interior also includes a wooden material, and the wooden material is using the same theme as the facade, with the smooth, even surfaces contrasting the more articulated. And finally, we have the facade with its profile on the crest, and the solar facade facing southwest, where the expression varies depending on the time of year, the time of day, if it's cloudy or sunny. So we have a variation in that expression of that facade.
Excellent. Thank you, Rickard. So this concludes the presentations, and I'd like to welcome Maria back. And we have some questions come in, and potentially the first one is for you, Maria. At what stage of the project process do you think the decision on BIPVs should be taken? I'm thinking you've been involved in an urban scale and at a building scale.
I think it's very, very important to hold the possibility open already in a detailed planning scale. And that's because there you really decide the volumes and the shading and the irradiation coming to the building. But then I think Rickard also spoke about how putting a budget in an early stage from the real estate perspective. So before you decide about the budget for the whole project, you need to do to have that final decision.
Yeah, sounds good. And also one of the other questions that I think we've touched on is the carbon footprint and how you bring that into the equation. And potentially that could be part of a carbon budget, if you like, if we start asking the manufacturers, what is the footprint of your product? We need it because we are setting up this budget. So would there be other good questions? We've touched on maintenance, looking for support here in sifting through questions, but in general, do you find that the expertise is lacking in the process? Or do you find obstacles in explaining how, why, and the value? Or are we seeing that everyone's on board nowadays? What do you say, Rickard?
This process in making all this decision contains of several people, and when a certain number has got the experience from before, then they meet together and they won't face any problems. But so far we don't have that many people that have been working with this kind of integration of photovoltaics and building projects. So it's a little bit shaky sometimes. And also I think that at least I met that the expectations of architects are sometimes a little bit too low. We are not asked for consultants regarding energy and solar. So people turn to someone else that is more used to maybe electrical installations and not solar cells, and not solar cells that are integrated. So I think it's important to bear in mind that even though you don't think about it, someone in your project group could actually have something to contribute with. So we must help each other together in the project to find answers on the questions. Otherwise, we easily get into that feeling of uncertainty that makes someone we won't bother about the PVs and forget about them.
It's interesting. In the UK, it's more or less standard, prevalent use of what you call virtual PVs. It's part of meeting the regulations, actually. So in Sweden, we're not yet there in the regulating part of things, potentially because the grid is cleaner, so electricity is cleaner. There are other factors as well. But would you say that we would need that to be an international standard to get this going properly?
I could add on to what you said about regulation. I think that every time you use actually a certification system also that says that you should have a lower energy demand than the regulation says, PV usually comes up because you need to balance different aspects to get that low value with PV. But then the PV comes very late and they become an add-on at the surfaces you have left. So I think to change that and to start thinking of that factor early, it's really important. And David, maybe.
Don't know, David, do you have anything to add to this? If not, I have a specific question for you, I think.
Yeah, please take that one.
This is, would you say there's a difference in lifetime or use for, if you compare traditional PVs that you have on the roof, like the virtual ones, to the ones that you integrate in the facade?
I would say that's a tricky question, and I would say generally no, not so much. Probably PV will last a long time. In the business or in the industry, we talk about 30 years for standard modules, but the warranties could differ. But in general, sometimes we also talk about that modules with double glazing. I mean, standard modules have glass and a plastic sheet, and if you have double glazing, that would tend to increase the lifetime of the product, and most BIPV products are double glazing as well. So yes, there could be a higher lifetime for the BIPV products. Okay,
so potentially better to integrate than have them as a late add-on.
Potentially, yes, but
okay.
It's more to that. We can discuss more in the workshop.
So, and this is a question open to the floor, really, maybe the last one. Or potentially more for Maria, but feel free to jump in. Do you find that there is a resistance in planning because the PVs then inform the design and they promote a specific facade cladding that could potentially be something that someone could have a problem with?
I think my experience is that it's actually a lack of knowledge. And we have looked in this international project, we have done surveys and found that this is a very important factor in all the countries. So you need to have knowledge about this as a material in the early stages. And in Sweden, we sometimes also maybe go too far in addressing what materials there are to be or what angles. So I think that planners should think about what flexibility can you have in the plan in order to give room for different PV solutions.
I guess the industry at large needs to know more about how that design can look. And this is, I guess, is something that it's not stopping at PVs. It's everything we do from now on would need to be informed by sustainable means of design. So there's a specific question here now. It could be tricky, David, for you. You had a cost per kilowatt. And the question is, how do you translate the installed kilowatts to hourly production in Stockholm? It's very specific, but maybe that's something we could sort of
we can look into detail also in the workshop, but generally you could say that 1 kilowatt of installed capacity will correspond to approximately 1,000 kilowatt hours per year on a good orientation. That means a south-facing roof, and it will be less in any other direction. So on a facade, it could be like 700 kilowatt hours per year, yeah. Then we can look into other orientations as well later on.
That's a good answer. I would like to again promote the workshops. The idea for this workshop, or there will be 2 of them, will be that you register and you bring your project specific queries to the workshop, and then you get help implementing BIPVs in that workshop. So you will have access to all of these brilliant minds, and you will also then discuss in the workshop format with others. So do look out for those invitations and how to register. I don't know how much time we have left. It's only a minute, actually. So potentially this is time for thank yous very much. Thank you so much for spreading some or shedding some light on this, and thank you all for joining. I hope you found this interesting, and again, we will answer all questions not answered in the webinar itself at a later point in time. Thank you all.
Thank you.
Thank you.